Okay, so here's our problem. Okay, so as we saw, we wanted to find specific gravity as a function of h over r. Okay, so the first thing we're going to do is we're going to draw out the log. Okay, so now we're going to define the radius is r, and then this will be the water level, and then h will be the distance from the water level to the top of the log. And then we're also going to have L, which will be the length of the log. Okay, so we know that the specific gravity equals the density of the log over the density of water. Okay, so we know from Newton's law that force equals mass times acceleration. And in this problem, the log isn't moving, so we can ignore acceleration, so that'll just be 0. And so then we also know that it equals buoyancy force minus the force of gravity. And the buoyancy force is the weight of fluid displaced. So now we're going to rearrange this equation. So we're just going to put the gravity on the other side. So we have the buoyancy force is equal to the force of gravity. Okay, what else do we know? Well, we know that weight equals mass times gravity. And we also know that density equals mass over volume. And so what we're going to do is we're going to solve for mass. So mass equals density times volume. So we're going to plug this back into this equation. And we're going to do this for the buoyancy force. So the buoyancy force is equal to the mass of the water times the area, and the area is of the part that's submerged, so this shaded region, times the length, and times the gravity. And we notice here that the area times the length, this is the volume part in this equation. Now we're gonna solve for force gravity. And so we know that the density of the log times the area times the length times gravity. And we know the area of a cylinder is pi r squared. So we're going to rewrite that equation equals the density of the log times pi r squared times L times G. So we're going to highlight those. Okay. So now the next thing we're gonna do is we're gonna rewrite this equation up here with these values. So we have the density of water times the area times the length times gravity equals the density of the log times pi r squared times the length times gravity. And we notice these two terms cancel out the equation, so we're left with the density of water times the area equals the density of the log times pi r squared. Okay, now the next part we're going to do is here. So I'm going to make it clear. I'm going to draw a picture, more up close version. So we have our radius, and then we have the water level, and then we have the height, and then by definition this will be the radius minus the height. And then we're also, for this length, we're going to define it as x. So what do we know? We know that by the Pythagorean theorem that a squared plus b squared equals c squared. So now we're going to substitute these side lengths in. So we have x squared plus r minus h squared equals r squared. Okay, now we're going to solve for x. So we get x equals the square root of r squared minus r minus h squared. Okay, now we're going to do some algebra, and we're going to figure out that r squared minus 2rh plus h squared. And now, since there's a negative sign, we're going to do that with, we're going to subtract it with these values, so this will become a negative, this will be a positive, and this will be a negative value. And so the r squared terms will cancel out. So we're going to be left with x equals the square root of 2rh minus h squared. Okay, so now what else do we know? We know that the area of a triangle is 1/2 base height. Okay, so now we're going to plug the numbers into the equation, or variables, and so we know that area equals 1/2, then we have 2, because we're going to take the value of both triangles. So we're going to do 2, the square root of 2rh minus h squared, r minus h, and that will be our equation for the area of the triangle. Okay, we're just going to label that the area of the triangle here. Okay, so now we need to find, we're going to label this theta. We need to find the value of theta. So how we do this is using our rules of the triangle. We know that cos of theta equals r minus h over the hypotenuse, which is r. And then when we solve for theta, we get theta equals arc cosine of r minus h over r. Okay, now we're gonna shift papers here. Let's see if I can push this up a little bit. We're just gonna shift papers. Okay, so now from that knowledge, we can solve for the arc. So we're gonna solve for this piece here, this chunk. Okay, so we know that 2, and we're doing 2 because we want to do the whole arc, so we need both of these angles, and so we're going to do 2 arc cosine of r minus h over r over 2 pi r squared minus, and now we're going to do the area of the triangle we found. So this equation right here, so minus the square root of 2rh minus h squared, r minus h. Okay, so now this is going to allow us to find the area of the top right here, this shaded region. Okay, so now we know the area of the top equals, and we know, we can see here that the 2's cancel out and pi cancel out, so we're left with r squared, r cosine of r minus h over r, minus the square root of 2rh minus h squared, r minus h. Okay, great. So now we know the area of the top, And the thing we want to find now is we want to find the area of the bottom. So this unshaded region is what we want to find out, all this white. And here, I'll just circle that to make it clear. So how we want to find this is we're going to take the whole area and subtract it by the shaded region. Okay. So we know that, and we're also going to plug our value of the area of the top back into our equation up here. So this equation right here. So when we do that, we get the density of water times pi r squared minus r squared arc cosine of r minus h over r, or minus h, my bad, minus the square root of 2rh minus h squared r minus h equals the density of the log. I'm trying to make sure that this is all in view, sorry. The density of the log times pi r squared. Okay, now we want to find the density of the log, so we're going to divide this whole side of the equation by pi r squared. Okay, so when we do that, we get the density of the log equals the density of water times 1 minus 1 over pi arc cosine of 1 minus h over r minus 1 over pi r squared, the square root of r squared 2rh minus h squared over r squared, and then r minus h over r. Okay, so now we're going to simplify this further because, as you can see, you can cross out some values and some terms. So when we do that, we're left with the density of the log equals the density of water times 1 minus 1 over pi arc cosine 1 minus h over r minus 1 over pi r squared, the square root of 2h over r minus h over r squared, 1 minus h over r. And then we can actually just cross out these values too. Okay, so now we know that from the original equation here that I showed you guys, the specific gravity of the density of the log over the density of water. Actually, I'm just gonna write this out for you guys. So the specific gravity equals the density of the log over the density of water. Okay, so as you can see here that when we put the density of the log over the density of the water, both of these terms cancel out. So we're just left with this term. So I'm going to write this out for you guys. So we get, my bad, the specific gravity equals the 1 minus 1 over pi arc cosine of 1 minus h over r minus 1 over pi, and then square root of 2h over r minus h over r squared, 1 minus h over r. And this is our equation. So I'm just gonna put a box around it, and I forgot the parentheses here, but okay, cool. So now we'll move on to part 2 of the video. Okay, my bad. I just realized that part of the answer is cut out in the last video. So here's the full answer of the problem.